repeat that because I just... Okay, so stoichiometry, that which you persist in doing becomes, not the, try that again. That which you persist in doing becomes easy to do, not that the nature of the thing has changed, but your power and ability to do so has increased. Just like riding a bike. First it's hard, after a while it gets easy. So we're balancing right now number 1. Has anybody got it done? Okay, go ahead. So 7. Not quite balanced. This right here is just a comma right here, so ignore that. Okay, ignore that. That's really not there. Okay, so let's see if we can do it together. So if you have 4 carbons, you need 4 carbons. So you would put a 4 here. You have 10 hydrogens, you need 10 hydrogens, you put a 5 here. Now as you're looking at your oxygens, you only have 2 on this side, but you have 8 plus 5, which is 13 on this side. Anybody remember the trick? Fraction for just a second. 13 halves will balance it, right? But I can't leave the half there, so what do? Times everything through by 2. So 2, 13, 8, whoa. Sorry, moved that when I wasn't meaning to. And 10. Okay, so now all we're wanting to do is do little ratios. So C4H10, what's in front of that? A 2, divided by what's in front of oxygen? A 13. So we're just setting up molar ratios. So next one here, what's in front of O2? 13, divided by what's in front of CO2? 8. Okay, would you do the rest of them real quick? No, do not simplify. You'll end up messing yourself up. Good question, though. There we go, finally. Okay, so I'm going to skip down to number 3. I'm going to do a couple with you when you feel comfortable. We can get the computers out. You can work on more of this. I want to do 3 and 4 with you for sure. Okay, and then if you feel comfortable, we'll leave it at that. So first thing again we need to do is balance the equation. You're always going to want a balanced equation. This one's fairly simple. What do I need to do to balance it? Good, I just have to put 2 2's in there. And this actually becomes 2 problems. This part is A, and this part is B. So there's actually 2 problems in there. I'm going to divide it vertically so I can get both problems in. So actually horizontally, I can't get my vertical and horizontal right, but that's okay. Okay, so we're going to start. I always, when I'm rating story problems, I'm one of these people, I have to pull out what I have. So I'm trying to get to grams of KCl, and I've got grams of K. So I'm going to start with grams of K. 2.50 grams of K. And I start with my stoichiometry, my factor label, or dimensional analysis, whatever you want to call it. What's the first step? Find the mass to change it to moles. Good. So we're going to put 1 mole of potassium on top, because whenever I go from mass to moles, it's always 1 mole. I look up on the periodic table to potassium, and it is 39.098. I ran out of room there, so a little 8. The grams, potassium are out now. Now I'm in moles. This is good because now I can go to the balanced equation and can change from moles of one thing to moles of something else, just like we did with our fractions up above. I want to get rid of K, so it's got to go on the bottom. What's in front of K? 2. So I'm going to put 2 moles K on the bottom. I want to get to KCl. So what's in front of KCl? A 2. So I'm going to put 2 moles of KCl. At this point, I can cross out moles of K. Now, we need to go from moles of K to grams again. So I'm going to put 1 mole of KCl on the bottom. And this is where I'm going to have to grab my calculator and add up a potassium plus a chlorine. And potassium is that 39.098, and the chlorine is 35.453. What do we get? 74.551? What did you said? Okay, at this point we can cross out moles. We can also cross out those 2's because 2 divided by 2 is 1. We can times the 2.5 times the 74 divided by our 39. And we have 3 significant figures, so let's give us an answer. .767, so 77 grams of KCl. Okay. I'm going to switch to red for the second part. On the second part, we're given 1 gram of Cl2 and excess K, and they still want us to find grams of KCl. So we're going to start with 1.00 grams of Cl2. What was the first step again? Change to moles. So I'm going to put 1 mole of Cl2 on the top, and rather than put it through my calculator, I'm just going to write this in like this. 2 times the mass of chlorine. So I can move on, because I know I'm going to have to put it in my calculator later. Now what was the next step? Who remembers? I go back up to the equation and find out what's in front of the 2 things that I want to use. What do I want to get rid of? Cl. So it goes down on the bottom. So 1 mole Cl2, because that's what's at the coefficient. And on top, I put 2 moles of KCl. At this point, I can cross out mole of Cl2. Last step will be just like the one we did up above, because we're going to grams of KCl. So it's going to have 74.551 grams of KCl divided by 1 mole of KCl. Those will go out. Now, on this one, make sure that as you times through the top and go to divide, you put the bottom in parentheses so that you'll get the right answer. That's one of the biggest mistakes that I see, is they forget the parentheses on the bottom. What do we get? .10 grams of KCl. Okay. So as we go on to number 4, we're going to balance number 4. What do we need to do to balance number 4? I'm going to go back to the blue. What's it take to balance number 4? 2 in front of what? NaOH. Okay, so it's balanced. This also has a part A and a part B. So we're going to do each of them separate. You'll notice that the numbers are given this time in scientific notation. How many grams of NaOH are produced from this many grams of sodium oxide? So I can leave it in scientific notation, or I can quickly convert it because it just is 2, so I just move the decimal 2, and it would be 120 grams of Na2O. Okay, so first step again, I want to get to moles. So 1 mole Na2O. What happens if I started with moles? Would I have to add things up? No, I can go right to the equation. If I was here and I had 120 moles of Na2O, I wouldn't have to add things up. I could just go right to the equation and do the swap. Okay? But since it's in grams, I have to be in moles before I go to the equation. Did anybody get Na2O added up? So sodium is 22.99 plus an oxygen at 15.99. So we needed 2 sodiums. Okay, do you have a second on that? Okay, awesome. Okay, so now we go back to the equation and we look at what's in front of Na2O and what's in front of NaOH. Which ones goes on the bottom? Na2O. So 1 mole Na2O and 2 moles NaOH on the top. Moles go out. Last conversion, what's it going to be? Oh, sorry. I need to go from moles of NaOH to grams of NaOH. So has anybody got that added up? Should be close to 40, I think. Okay, moles go out, taking times to the top, divide by the bottom, since there's only one number on the bottom that's not, that's not a 1. We don't have to put in parentheses. Should be about 160. So it is in 0.8 to 155. Oh, come on. NaOH, is that what you guys got? 3 sig figs? Okay. Let's go look on the next one, and then I'll let you decide if you want to stay with me or not. Okay, on B, so that was A. On B, how many grams of Na2O are produced with sodium hydroxide? So again, we can move this 2, and it would be 160 grams of NaOH. And this time we're going backwards from what we did in A. So we're going to go from grams to moles. So we're basically taking this last conversion and flipping it. So 39.997 grams NaOH. And on top we put 1 mole. Grams go out. Then we're going to go up to the equation, and we're going to go from these 2. We wanted this time get rid of NaOH, so it's going to go on the bottom. So we put 2 moles of NaOH on the bottom. And on the top, we're going to put 1 mole of sodium oxide. Moles will go out. And then the last conversion is this conversion flipped. So 1 mole Na2O and 61.979 grams of Na2O. Moles go out. This time we need to make sure that we remember to put divide and parenthesis around the bottom, because there's more than one number that is not a 1. Should be about 120. About. Anybody got that through? About 120, I guess. 123.9, so 124 grams Na2O. I did that quick because 160 divided by 2 is 80. 80 divided by 40 is, okay, and times it by 2. Okay, that's how I did it real fast. Okay, so how are you feeling about these? Because you have to do a problem like this on the test. And there's one, you'll have to do at least a problem like this on the test. You'll need to do one with limiting. Tell me which one's a limiting, like you've been doing on your sapling. Okay, which one is over? Which one you have more of? How much more do you have of it? Okay, there'll be one like this on the exit exam or exit quiz today too.
Have you made a study guide yet, like online, the video?
The review is online, should be online. Yes. It is multiple choice.
When is it again?
Friday. It is Friday.
Questions is it?
It was between 32 and 40. I can't remember. Okay. Okay, but remember, you got it. Of your grade, 60% of this is this test. Okay, so this is where you can, well, all the tests. Yeah, this test is 60% of your grade for the rest of the year. No, your tests are 60% of your grade. So if you can do really, really well on a test, that really ups your percentage. Okay, so I went over last time redox. This time we've gone over Stoic. You need to make sure that you go through my review video that's online so that you can get through some other things. The things we're going over in the quizzes are stuff that is on the test. I just tweaked something, used a different equation, or but it's asking the same kind of stuff.
What would you advise us to have on our study card?
Whatever you don't know how to do. This chapter is very, very broad. So whatever you don't get, I would take and I would go through the chapter in your book and say, okay, chapter point 1. Do I get that? Great. Point 2. Do I get that? Look at the problems at the back of the book. Remember I told you, or not the back of the book, but the back of the chapter. I told you those are good ones to see what kind of questions might be asked in that section. Okay? She does do it according to the learning objectives. So look at the learning objectives at the very beginning of the chapter. Okay, there's usually about 4 to 6 questions on each learning objective. Okay? All right. Time is yours. You can work on sapling, you can work on this to get more familiar. It doesn't matter which one. If you're going to grab a computer from me, remember you get to trade me something now. And then we'll come back together at about 7 or 8 after, so we have enough time. There's 10 questions in the exit exam. So I want you to see how you do on that. And that one is a stoichiometry problem, the last one, so it will take a little bit more time. Okay, it's not a hard one.
The other questions in that, is that just the redox reactions?
The redox reactions, what's oxidized, what's reduced, all that fun stuff again. Okay, all right. Okay, we'll go with what we're doing right now.